We're coming back to look at two other kinds of combined fragment. We've looked at parallel structures and loops in the first movie. And now in the second movie, we'll look at decisions that are the equivalent of if-then statements and those that are the equivalents of if-then-else or case statements. Then I'll list the other types of combined fragments that we don't cover here. These two types of combined fragment use the keywords alt and opt. Alt is used where there are two or more alternatives, as with an if-then-else statement, or for a switch or case statement. Opt for option is used in those situations where there is just one action that must be carried out or not carried out, depending on some condition, equivalent to an if-then statement. Here's a sequence diagram with an alt combined fragment in it. The intention here is to improve the interaction occurrence test device by adding in a timeout, so that if the device being tested doesn't respond within a certain amount of time, it can be reported as not existing. The combined fragment is shown as a frame with the keyword alt in the top left and has two interaction operands, each with its own sequence of messages in it. The two interaction operands have been marked with the conditions device responds and timeout. In this version of the diagram, the device manager sets a timer for 4,000 milliseconds at the start. Then it sends a signal to the device. If the device responds before the 4 seconds are up, the device manager stops the timer and reports that the device exists. Otherwise, the timeout occurs and the device manager reports that the device does not exist. This diagram shows an opt combined fragment inside a loop. This is shown by the keyword opt in the top left. The loop works through all the timed events in a schedule, getting each timed event in turn and checking if the time of that timed event is equal to the current time passed in as a parameter. If it is, then it sets found equal to true. The loop has a condition on it that checks for the value of found each time round and will exit from the loop if it is true. So as soon as it finds a timed event for the current time, it exits the loop. This is the lower part of that same diagram, showing an alt combined fragment. After the loop is completed, then if found is true, it returns the timed event at position I in the collection. Otherwise, it returns null. There are some other types of combined fragment that are less widely used. Of these, you're more likely to see the first three than the others. Break is for a fragment that breaks out of the enclosing fragment. Assert is for a fragment that represents the only valid sequence through an interaction. Critical is for a sequence of interaction that takes precedence over others in a parallel combined fragment. The others are all listed in the UML specification. Now let's add alt and opt combined fragments in Enterprise Architect. So here we are in Enterprise Architect. I want to add a new sequence diagram called process schedule, so I'll add another package to the interaction view. I'll call this process schedule. I want package only, and I'm then going to add an interaction. I call that process schedule as well. Here's the new diagram. I want two lifelines in this diagram, one for schedule and one for timed event. I'll add them both from the toolbox. I call this one schedule, and I set its instance classifier to be schedule from the main package. I'll call the second events square bracket I square bracket. So this is going to be an item in an array or collection. It's referenced by the index I. I'll set it to be an instance of the class timed event. I'll add a gate where a message will come into this interaction occurrence, and I'll call it event now. I'll add a message from the gate to the schedule lifeline. I'll add an operation to the schedule class, which is the way you should do this properly, and I'll call it getEventNow. I'll give it a parameter called timeNow of the type time of day, and it will return a timed event. I'll set the argument to now. You can see the message name on the arrow. Now I'm going to add a loop combined fragment. I select loop from the drop-down list. According to the UML specification, what I should enter here is the lower bound, which is 0, comma, and then the upper bound, which is number of events minus 1, in round brackets. However, this is free text, and I prefer to add something that references the variable I'm using as a loop counter. So I'm going to put in I equals 0 and I equals number of events minus 1. I also want it to end the loop if found is equal to true. So I'll add an interaction operand condition found equals true. Now, inside the loop, I'm going to add a message from schedule going to itself, calling its operation getTimedEvent, which already exists. And I'll pass it the argument I. Then I need to call the getTime operation of timedEvent. This needs to be set as an operation at some later stage. I'll assign the returned value to event time, and it won't be void, it will be time of day. Now I can add the opt combined fragment. I click on Fragment and on the diagram, and I select Opt. I add event time equals now as the condition for the interaction operand. And you can see it inside the combined fragment. So if this condition is true, I need to set found to true. So I'll add a message set found equals true. So if found is set to true, then this condition found is equal to true will be true, and so the loop will terminate. So finally, I need to add an alt combined fragment outside the loop. I add it from the toolbox. It needs two interaction operands, one called found equals true, and the other called else. You can see that it's created two compartments inside this for the two interaction operands, one labelled with found equals true, and the other labelled else. I need a gate for the reply, which I'll call event now reply. So I draw a message from the schedule lifeline to the gate in the first interaction operand. I set it to be a reply message, and I'll call it getEventNow, and I'll set the return value to be events I. Then I draw another message between the schedule lifeline and the same gate. This needs to come from the other interaction operand. The two are mixed up here, so I need to move this one up. I also set this to be a return. It's also called getEventNow, and it returns null. So we've now added both an alt and an opt combined fragment to this diagram. In this chapter, we've added a number of sequence diagrams. We started from the use cases, adding a sequence diagram for the use case add a device. This diagram shows lifelines and messages as well as states on lifelines. We added an interaction occurrence here and can follow it to the referenced diagram by double-clicking it. This reference diagram includes asynchronous messages and signals. We also added timing and duration constraints. Finally, we've added combined fragments, and in the sequence diagram for run home automation, we've added parallel and loop combined fragments. And we've now added alt and opt combined fragments to the sequence diagram process schedule.